You think light is weightless, harmless, something you can bathe in on a summer afternoon. And you're right. Sunlight warms your skin, fills your eye, bends through a raindrop into color. But here is what no one tells you. You have never touched it. Not once, not a single photon, a tiny packet of light energy has ever made contact with your hand, your face, or anything else. And if you could somehow catch one, hold it still for even a fraction of a second, the entire framework of reality as we know it would snap. I'm not exaggerating. Let me show you why. Imagine you are standing in a dark room. I flip a switch. Light floods the space in roughly 3 nanoseconds. 3 billionths of a second. You see the walls, the chair, my face. It feels instant, but here is the question we will chase to the end. Why does light move at all? And why can nothing, no hand, no wall, no cleverness, ever stop it mid-flight? The obvious answer is that light is fast. Fine, but speed is not the issue. A bullet is fast. You can catch a bullet in a thick enough block of steel. The steel slows it, stops it, done. So why not light? You might think, well, light has no mass, no weight, so there is nothing to grab. Closer, but still wrong. Because I can grab things without mass all the time. I can trap a magnetic field inside a coil of wire. I can bend the shape of space itself near a heavy star. And light will follow that bend. So the problem is not that light is untouchable, because it is weightless. The problem is deeper, and it begins with a fact so simple we forget how strange it is. Light does not experience time. Let that settle. To a photon, the moment it leaves the surface of the sun and the moment it strikes your retina are the same moment. There is no journey, no duration. From light's perspective, if we can even use that word, the universe is compressed to 0 thickness. You live in time. Light does not. And that is the first crack in the floor. Now, you might say, fine, Einstein, light is strange, but I still see it, so it must interact with something. Yes, it interacts with electrons, tiny charged particles inside atoms. When light hits your eye, it does not bounce off like a tennis ball. It is absorbed. The photon ceases to exist. Its energy kicks an electron into a higher state. A chemical signal fires and your brain says, I see red. The photon is gone, not slowed, not resting, gone. So when I say you cannot touch light, I mean this. You cannot hold it. You cannot slow it down and place it on a shelf. You can only destroy it, and in that destruction, convert it into something else. Heat, motion, a chemical change. Touch, as you know it, requires 2 objects to meet, press against one another, and remain. Light does not remain. But now the question twists. If light is always moving, always at the same speed, never resting, what is pushing it? A car needs fuel. A river needs gravity. What sustains light's motion? And here is where your intuition will fail you. Because the answer is, nothing is pushing it. Light is not being driven. It is the natural state of something with no mass, moving through space. To stop light, you would need to give it mass. And the moment you do that, it is no longer light. We are about to meet a clock that runs faster simply because it floats higher above the earth. And when you understand why that clock does not agree with yours, you will understand why light cannot stop, and why touching it would mean touching the edge of time itself. We begin with something ordinary, a satellite circling the Earth 20,000 kilometers above your head. Inside it sits a clock, an atomic clock, built to tick with absurd precision, 1 tick every billionth of a second, steady as the universe allows. You have a matching clock here on the ground. Both are perfect. Both started synchronized. You wait 1 day, then you compare them. The clock in the sky is ahead. Not broken, ahead. It has lived through more time than you have. Roughly 38 microseconds more per day. 38 millionths of a second. Tiny, yes, but undeniable. And if you are using those satellites to tell you where you are, If you are using the global positioning system, that difference will place you not on the street corner where you stand, but 11 kilometers away, in the wrong city entirely. So we fix it. We program the satellite clocks to tick slower before we launch them, compensating in advance for the speed up they will experience in orbit. They leave the ground running slow, they reach orbit, and then, in weaker gravity, farther from Earth's pole, they speed up to match your clock. Now your navigation works. But why did we need the fix in the first place? The answer is not mechanical. The clock is not broken. Time itself is running differently up there. Let me say that cleanly. A clock does not measure time the way a ruler measures length. A clock participates in time. It is made of atoms, and atoms are made of charged particles, and those particles interact by exchanging photons. Every tick of every clock, mechanical or atomic, is built from internal events that depend on light moving between parts. And light, as we have established, does not experience time. But you do, and the rate at which you experience time depends on where you are standing. Gravity is not a force pulling you down. I know that sounds wrong. You feel weight. You feel the floor pressing up against your feet. But that pressure is not gravity. It is the floor blocking your natural path through space-time. Gravity is a bend, a curvature in the fabric of time and space together. Near a massive object like Earth, that fabric is stretched. Time runs slower. Far from Earth, the fabric relaxes. Time runs faster. The satellite clock is not ticking faster because it is in space. It is ticking faster because it is in weaker gravity, because the curvature of space-time there is gentler. The ground clock is ticking slower because Earth's mass presses down on the fabric of time around it. You are living in a thicker medium. The satellite is living in a thinner one. Now, what does this have to do with light? Everything. Because light defines the speed limit of causality. The fastest that any influence, any change, any signal can travel. And that speed, the speed of light, is the same for everyone. Everywhere, no matter how fast you are moving or where you are standing. That constancy is not a coincidence. It is the rule that forces time itself to be flexible. Imagine you are holding a flashlight. You flick it on. The light moves away from you at 300,000 kilometers per second. Now imagine you are on a train moving half the speed of light, and you click the flashlight on again, pointing forward. You might expect the light to move faster now. Your speed plus light's speed, but it does not. The light still moves at 300,000 kilometers per second, measured by you, and also measured by someone standing still outside the train. Same speed, always. For that to be true, time and space must warp around you. Your clock must run slower when you move. Your ruler must shrink in the direction of motion, not because clocks and rulers are fragile, but because time and space themselves are not fixed stages. They are dynamic, responsive, coupled, and light is the messenger that stitches them together. So when you ask, why can I not touch light? You are really asking, why can I not catch up to the thing that sets the pace of time itself? And the answer is becoming clear. To touch light, you would need to move alongside it. To move alongside it, you would need to reach light's speed. But as you accelerate toward that speed, your clock slows down. Your mass effectively grows. The energy required to push you faster grows without limit. You approach light speed asymptotically. You get closer and closer, but never arrive. And if you somehow did reach it, if you could move at exactly the speed of light, your clock would stop entirely. You would experience no time. You would become, in a sense, timeless. You would no longer be matter as we know it. You would be something else. Now here is the part nobody tells you. Light is not moving through space the way you move through a room. Light is the baseline. You are the one moving through time, and the speed of light is not a speed limit on motion. It is the conversion rate between space and time. Let me make that concrete. Right now, you are sitting still. At least you think you are, but you are moving through time at a very specific rate. 1 second per second, you might say? Trivial. Obvious. Except that motion through time is still motion. You are traveling, always, through a four-dimensional shape we call spacetime. And the total speed of that travel, your movement through space plus your movement through time, is always the same. Always exactly the speed of light. When you stand still in space, all of your motion is through time. You age at the normal rate. But when you start moving through space, when you walk or drive or ride a rocket, you are tilting some of your motion away from the time direction and into the space direction. You are still moving at the same total speed through space-time. But now less of it is aimed at time, so your clock slows down. You age less. The faster you move through space, the slower you move through time, because the total speed is fixed. Light is the extreme case. A photon moves through space at full speed, 300,000 kilometers per second. That means it has zero speed left over for time. It does not move through time at all. It is purely spatial. That is why, from the photon's perspective, there is no journey. Departure and arrival are simultaneous. The photon does not age, does not wait, does not evolve. You cannot touch light because you cannot join it in its frame of reference. To do so, you would need to stop moving through time entirely. And if you are not moving through time, you are not experiencing causality. You are not a process anymore. You are frozen, in a sense, not in space, but in time. You would not be conscious. You would not be anything we recognize as existing. So here is the twist. Light does not refuse to be touched because it is fragile or because it is too fast. It refuses because it lives in a different mode of reality. It is the boundary condition, the thing that separates experience from non-experience, time from timelessness. But let us go one step further. Why does light behave this way in the first place? Why must something with no mass move at this fixed, unbreakable speed? The clean version is this. In our universe, space-time has a structure. That structure allows influences to propagate, cause to lead to effect. The maximum speed of that propagation is built into the fabric itself. We call it the speed of light, but that is a historical accident. It would be better to call it the speed of causality. Light simply happens to travel at that speed because light has no mass to slow it down. Anything with zero mass must move at that speed, always, no exceptions. Gravity, for instance, if we could detect its ripples directly, moves at the same speed. Not because gravity is made of photons, but because both are massless influences propagating through space-time structure. The speed is not about light. It is about the universe's wiring. Now, remember the GPS satellites? The clocks running faster in weaker gravity? That is not a side effect. That is space-time showing its hand. Time is not universal. It is local. It bends, stretches, flexes, depending on mass and motion. And light is the ruler we use to measure that flexibility. Because light's speed is the one thing that does not bend. It stays constant, even as time and space warp around it. So when you try to touch light, you are trying to touch the measuring stick itself. You are trying to grab the standard against which motion and time are defined. And you cannot. Because the moment you reach that speed, your time stops, your perspective collapses, and you are no longer an observer. You have become part of the boundary. There is one last question, and it is the hardest. We can predict all of this. We can measure it. The math works. The satellites prove it. Particle accelerators confirm it millions of times per day. But do we know why the speed of light has the value it does? Why 300,000 kilometers per second and not some other number? No, we do not. We can measure it. We can build our physics around it. But the universe did not hand us a receipt explaining why it chose that number. It simply is, and everything else follows. You are standing in that dark room again. I flip the switch. Light crosses the room in 3 billionths of a second. You see the walls. You see my face. And now you know that light did not travel to you the way a message travels. It did not experience the journey. It was emitted and absorbed in the same instant from its own perspective. The 3 nanoseconds you experienced were yours alone. The photon had no such time. Touch requires two things to meet in time and space and persist together. But light does not persist. It is always in the act of vanishing. When it strikes your retina, it does not bounce. It ends. Its energy becomes something else. An electron jolts, a molecule changes shape, a nerve fires. You do not touch the photon. You inherit its consequence. Think back to the satellite, the clock ticking faster above you. That was not a malfunction. It was a confession. Time is not the invisible river we pretend it is, flowing the same for everyone. It is local, personal, shaped by where you stand and how you move. And the only reason we noticed, the only reason we had to correct those clocks, is because light holds steady. It refuses to change speed, no matter how we twist space and time around it. Light is the constant. We are the variables. So when you ask why you cannot touch light, you are really asking why you cannot step outside time. And the answer is because you are made of matter. Matter has mass. Mass curves space-time. Mass moves through time. Light has none of that. It is pure motion, pure change, happening at the only speed the universe allows for things that have no inertia, no resistance, no need to age. Here is the reframe. You think of yourself as solid, real, persistent, and light as fleeting, weightless, almost not there. But from the perspective of space-time itself, light is the stable one. Light obeys the one unbreakable rule. You are the flexible thing, aging, slowing, bending under gravity's hand, never able to reach the speed where time stops because you are trapped in time's flow. Light is not trapped, it is free. And that freedom is exactly what makes it untouchable. We have built our entire technological world on this fact. Your phone's clock, synchronized with satellites, medical imaging that tracks particles moving near light speed, fiber optic cables where pulses of light carry information faster than electrical signals ever could. We do not touch the light. We aim it, absorb it, convert it. We live in its consequences. But here is what still humbles me. We can predict where a photon will go. We can describe how it bends around a star, how it shifts color climbing out of a gravitational well. We can write the mathematics that govern its every interaction, but we cannot tell you why the speed of light is exactly 299,792,458 meters per second. We cannot tell you why space-time is structured to allow that particular rate of causality and no other. We can measure it to extraordinary precision. We cannot explain why the universe chose that number. It simply did. And everything, your aging, your motion, your existence in time, follows from that choice. You have never touched light. You never will. Not because it is too fast to catch, but because catching it would require you to stop being a thing that experiences time. Light sits at the boundary between existence and timelessness. It is the edge of the board, the frame around the picture. You can see it, use it, be changed by it, but you cannot join it. To touch light, you would have to stop being you, and that is not a limitation. That is the structure of reality. Light moves, you age, and the difference between those two facts is what makes the universe knowable at all.